Hi, I'm Greg Sargent. I recently joined OSO as a developer advocate, and I'm really looking forward to talking to you today about authorization data, and specifically some of the considerations for managing authorization data in microservices environments. So just to briefly highlight what we're going to be talking about today, I'd like to sort of set the foundation for this conversation by talking about sort of the three primary concepts of an authorization operation, the query, policy, and data. And then we'll introduce sort of a sample application that we can use to sort of illustrate some of the considerations that go into modeling authorization data. Since it's Halloween, let's make that app a candy dispenser. We'll talk about how we can manage our authorization data as this application grows to encompass multiple services. We'll get into some considerations about how to model application data effectively for authorization purposes. And then we'll talk about sending that authorization data to an authorization service. And then finally, Sam will do a demo of some tooling that we've been putting together to make this a little simpler. So when we speak of authorization at OSO, we speak in terms of really three primary elements, the query, the policy, and the data. We do get a fair amount of feedback and a lot of questions from people who would like us to clarify sort of what those three elements are and how they interrelate with one another. So before we get into sort of a deeper conversation about authorization data, I thought it would be helpful to set the context for the conversation by illustrating those elements, and what better way to do this on Halloween than with a spooky story. So we can all imagine ourselves a few hours from now after this webinar is complete, sort of tucking into our homes and getting into the Halloween spirit by turning off all the lights and maybe putting on maybe a small reading lamp next to us and pulling out our favorite horror story and reading a good scary story to get us into the mood for Halloween. And the sun will have set by then and it will be dark outside. Maybe there's a bright moon in the sky, some light mist sweeping across the ground, and wind howling through the trees. And just as we're sort of settling in and getting absorbed by our scary novel, out of nowhere, there's a knock at the door. And we're startled from our reverie. We drop the novel, perhaps literally, get up out of our chair and sort of slowly approach the door, hands trembling. And as we open the door, we are encountered by a horrifying skeletal bear. And the bear looks deeply into our eyes and reaches out a paw and asks us, "May I have some candy, please?" And once we've sort of recovered from this initial shock, we realize, well, I don't know. I'm not sure if I should give you some candy. I need a little bit more information before I can answer this question. So let me see. If you're a friend, I would definitely give you some candy. I always give candy to my friends, but I don't know any skeleton bears, so I don't think you're a friend of mine. So I can't really give you candy on the basis of you being a friend. But you're in luck because it's Halloween, and I can give candy to strangers on Halloween as long as they're in costume and say trick or treat. So the initial shock wears off, and I realize, this is probably not really a skeleton bear. I don't think that's a real thing. I'm suspecting that this is a person in a costume. So it is Halloween. I have a person in a costume, but unfortunately, although it was a very polite person in a skeleton bear costume, they didn't say trick or treat. They asked, "May I please have some candy?" So I'm very sorry, but I can't give you candy today. What I have just done, for all intents and purposes, is go through an authorization exercise, and in doing so, I've used all three of the elements of this model, right? So you can think of this process in terms of a decision tree, right? And in this tree, like, the query is really just the question that we're asking, right? That's what a query is. So I ask, is this person allowed to have candy? That's my authorization query. This needs to be subjected to a number of questions and rules so I can determine whether or not to give the person candy. The policy is just the set of rules or the set of questions that I ask in order to allow myself to answer whether any given person is allowed to have candy in any situation. Right? So in this case, the policy says that I can give someone candy if they're a friend, or if they're not a friend, I can also give them candy if it's Halloween and they're in costume and they said trick or treat. So that kind of comprehensive set of conditions that allows me to determine in any situation whether or not to give someone candy, that's my policy. The data then apply to a specific person or a specific instance of answering this question. So given a person, let's say Alice, who shows up at my door in a bear outfit, every answer to this question that is specific to Alice represents the data about this operation for Alice. So Alice approaches, Alice is not a friend, but it is Halloween and they are in costume, and let's say in this case they did say trick or treat. All of those responses are the authorization specific data for the case of Alice coming to my door in costume on Halloween and asking for candy. And so that is the data that we're interested in for this conversation. There's all sorts of other data out there today, whether what phase the moon is in and what book I was reading and all that. I'm not really interested in any of that for purposes of this conversation. All I really need to know is what I needed to know to answer the authorization question. So this is great. I had an opportunity to choose not to give someone candy based on an authorization model. I've dealt with my first trick-or-treater, but it's 2023. This was exhausting. I had to stop reading my book. I had to get up out of my chair. My heart was racing from the fright of this operation. I had to pull the door open. All of this is just way too much. Surely in 2023, there's a better way to do this. I should be able to write some software to handle this for me. So why don't we take this operation of handing out candy and write ourselves a little application to deal with it. So we'll have our little candy dispenser app. That application will need to have some data associated with it. Again, we'll need to know some things about the candy to dispense and where the candy is stored and all that. But for purposes of this conversation, the data that's really important to it is the data it needs for authorization. So, for our candy dispenser, it's going to need to handle an inbound request. Alice will approach my door, and the candy dispenser springs into action and says, not sure whether I should give Alice candy. Let me go get the data that I need in order to reach an authorization decision here. Right? And so it will go to the data store and fetch the data that it needs. So it needs to look up whether Alice is a friend. I know the date. I have to look up whether this date is Halloween, perhaps. I know some information about what Alice is wearing. I can see whether that's a costume, and I can verify that the greeting was the greeting that I expect for handing out candy. So my dispenser goes and it gets this data, applies the authorization logic to determine whether or not to give Alice candy, and happily this time Alice has come back and said trick or treat, and so the candy dispenser gives Alice some candy, and everyone is happy on Halloween. So this is fantastic. Now I can sit in my chair on Halloween and read my book, and my candy dispensing app happily hands out candy to all the trick-or-treaters who come by. And so this is now able to process the relevant data to make the appropriate authorization decisions every time someone comes by on Halloween or not on Halloween and requests candy. In fact, this worked so well that I want to do this for everything in my life. I have all kinds of other things that I need to do to maintain my relationships with my friends and do activities and that sort of thing. But they're all so much work, and there's so many little different things that I have to keep track of. Like it's all just too much. And again, it's 2023. I should really be able to be smarter about this and have a little bit more, have more software managing more elements of my life so that I can spend more time reading my books. So let's see if we can extend this into every part of my life. So another thing that I like to do with friends is go out to dinner, right? So maybe another good application to have in my friend management suite would be a dinner planner. So now, let's extend our application to include another service. So I've already got my wildly successful candy dispenser service, merrily dispensing candy as needed. Now I'm going to work on my dinner planner service. And planning dinner also has some authorization implications. I need to know, again, whether someone's a friend, because I don't want to go to dinner with a bunch of strangers generally. And for planning dinner, I need to know different things about them, whether they live nearby or not, so they don't have to drive hours out of their way, because they probably won't. And, let's say whether they're working or not that night, so I'm not inviting people who aren't available. So now I have two different services that are doing two different authorization operations to reach a decision. But one thing jumps out pretty quickly. Both of these services need to know whether the person is a friend or not, right? So I have this shared bit of authorization data that each of these services needs to act on, but it's not really clear which of these services should own this friendship relationship, right? It's really not a natural fit for either. And if I make either one the owner, then I have to start doing strange things like, if the candy dispenser is maintaining all of my friend relationships, then when I want to plan a dinner, the dinner planner has to ask the candy dispenser whether someone is a friend. This doesn't make any sense. It's not really a sensible way to organize the data. And we actually see this sort of thing, all the time in real world authorization operations, very frequently with things like, org chart type data. So roles within an organization, or, belonging to a specific company in a multi-tenant application, all of this sort of, org chart style data, needs to be used by multiple services in many applications, right? So perhaps I have a company and I have my HR system that has, highly sensitive confidential employee information that, company executives and people on the HR team can see, but no one else should have access to. But then I have the company handbook that everyone in the company needs to have read access to, but only certain people should be able to edit. And then, I have an engineering team, and only the people on the engineering team should be able to edit the code that that our application is built upon. So all of these different services that are part of my organization need to know this, org chart style data, these roles and relationships, but none of them really make sense for owning that data, right? So this is analogous to something that we see all the time in the real world. And what we've determined from working with a lot of people who encounter this situation is really the most sensible place to put this shared authorization data is in a common centralized authorization service, right? So the good news here is that we have already adopted a software architecture where our application is composed of multiple services, each of which is sort of purpose-built to handle a specific function well. So authorization is just another one of those functions, right? So now that I've already adopted this model and started thinking in terms of smaller individually targeted services, it's a little more straightforward for me to plug in an authorization service into this model. And now that authorization service is a very natural place to store all of this shared authorization data, right? So now I have my authorization service. It's responsible for maintaining all of my friend relationships. There's an authorization data store backing that service where I store all of this common data. And now any service that needs to access this data can reach out to the authorization service, right? So now my candy dispenser goes to the authorization service, my dinner planner goes to the authorization service, and both of those can get that friend data. As I add more services to manage my life, maybe there's a birthday present service that it hands out birthday presents to people. Maybe I need to organize carpools with friends and I have a carpool service. Now I don't need each of these services to also maintain this friend relationship in order to determine whether or not a certain person should get a gift or be part of the carpool, right? If I if I did this way, suddenly I would find this common authorization data being, sprawling all over my application. Instead, I just keep it in one place. I have a single source of truth for that data, and any new services that I add that need to make use of this common authorization data can access it through the authorization service. All of this other data that is not common, that is specifically used for making authorization requests for the application, can continue to live with the application services, right? There's probably other uses for this data inside these applications. I may need to know whether someone lives locally or isn't working, or I may need to know things about Halloween for all sorts of other reasons in the application. And so if I keep that application-specific data that has some implications for authorization closer to the application, I now can use it more effectively for core application functionality, right? So I don't need to make a call to remote service every time I need to use this data for something else. And so now my authorization operations are relatively quick because all of my common authorization data is one place, and all of my application functionality is also fairly quick because the application has all of the data that it needs for common application operations. So this is a nice, clean, sort of sensible architecture to put together here, but it does introduce a new wrinkle into our authorization flow, which is that now there is no single service that has access to all the data that it needs to answer most authorization questions, right? So instead of just being able to have the candy dispenser determine whether Alice is a friend and then is in costume on Halloween, the candy dispenser needs to talk to the authorization service, and we need to sort of exchange data between these two. So now to answer a given authorization question, what is the most effective way really to sort of marshal that data from multiple services? Well, we recommend that at the time when you need to perform an authorization operation that incorporates application-specific data, we should send that data from the application service into the authorization service, and then allow the central authorization service to act on all that data and apply the authorization logic, and then return the result to the application. The reason that we recommend this is really to make the evaluation of the authorization data more centralized and easier to follow. So if we did this in reverse, which is another approach we could take, we could say, you know what, the dinner planner knows about 2 bits of data and it only needs to pull 1 from the authorization service. So why don't I just pull less data from the authorization service? I could do that, and I could have the dinner planner ask the authorization service whether someone is a friend, and now it would be the dinner planner that has all of the data it needs to make the authorization decision. This means that the dinner planner also has to include the logic and the processing to make that authorization decision. But it's only going to be including that logic to make authorization decisions for planning dinners, right? And then by extension, the candy dispenser is going to pull my is friend data from the authorization service, and it will gather all of the data that it needs to make the authorization decision, and it will have to locally implement authorization logic to do that. And so what happens if we do this way is that now our authorization logic is spreading throughout our application, right? So if I need to understand what's happening with authorization across multiple services, I have to trace that logic through multiple services. There's no single place for me to look for it. I'm possibly complicating the operation of making a global authorization call, because I might have to incorporate 2 or 3 different services to answer a more complicated authorization question. So there's a lot more complexity involved, and I sort of eliminate one of the primary benefits of centralizing my authorization service, which is to centralize all of the authorization logic in one place. And by doing that, I have this nice purpose-built authorization service. I can tune it for authorization operations. I can have it scale out in response to bursts in authorization traffic without having to affect the other running applications and services. And so by feeding data from the application services into the central authorization service on demand when I need to gather that data together, I can really take full benefit of centralizing my authorization logic in a single service. So now we have sort of two kinds of authorization data. There is data that will live with the application and then we'll send along to our authorization service when it's needed for an authorization operation. And then there's other data that we will store in the authorization service for the long term because it's shared by multiple applications and needs to be used for authorization operations. This brings us to kind of another consideration. If I'm going to store data in an authorization service, if I'm taking data that I had been storing in my application and putting it in a store that backs a service that is being purpose-built for authorization operations, then it makes sense to sort of model that data in the store in a way that lends itself to performing those authorization operations very well. And so there are a couple of things to take in mind when we're thinking about how we want to represent that data. It probably doesn't want to look the same as it does in an underlying application data store because if you think about a relational database, right, maybe I have some relationships that are defined by a couple of tables that have a foreign key constraint defined, or maybe I have some attributes that I use for authorization that are Booleans or integer fields or enumerated strings. If I represent that raw data in those formats, I'm going to need to write new code every time I introduce new data into my authorization system because it's not apparent from that data what the authorization implication is of the data. I also, if I'm incorporating new data in that same structure, I probably need to modify my database right underneath in order to incorporate it. If I don't have a table that is used to express a relationship that I now need to encapsulate, then I need to add that table to my database. So I really don't want to have to do that sort of operation when I'm storing my data. So when thinking in terms of authorization data, I think three sort of key considerations come to mind. I would like that data to be structured, not structured in a sort of rigid relational model, but structured well enough that I can retrieve any specific piece of authorization data quickly when I need it. And I'm going to be making probably a lot of queries of this database. I make authorization calls all the time. All kinds of requests need to have some kind of authorization logic performed on them. I would like the data to be structured in such a way that it's easy for me to look up the authorization data that I need when I need it. I want that language or that data to be expressive, right? So what that means is I'd like to be able to describe a variety of different sorts of authorization relationships, ideally arbitrary authorization relationships, anything that I might need to model without having to write new code in order to tell my application what that data means, right? So that would be a fantastic characteristic of this language. And then I would also like it to be flexible. So I want to be able to use arbitrary source data. Maybe it's a Boolean, maybe it's a string, maybe it's a number, maybe it's a relationship between two tables, whatever that representation is in my source data. I would like to be able to represent that in this authorization data model, again, in a way that doesn't allow me or doesn't require me to change the database structure to incorporate it. So we gave a lot of thought to how best to balance all of these concerns. And what we've come up with for storing data at OSO is what we call a fact. And so facts are just a structured way of representing authorization data in a lightweight way that allows us to express arbitrary authorization models and incorporate arbitrary data into a uniform data structure, right? So a fact has this general form, so it has a name. It's usually something underscore something, and then a list of arguments. And so the name tells us what sort of authorization data is being represented by this fact, And the arguments let us know what sort of entities it applies to, if you will. So, I can have a fact that defines that someone has a role in a specific organization, and that could be a has role fact that defines who the person is that has the role and what the role is and what the organization is that that role is. Right? That's how we can sort of express things in fact. It's a little fuzzy in the abstract, so I think what could be helpful is to sort of show how this ties back to our initial model where we represented this as a decision tree, right? So if you remember back towards the beginning of the talk, one of the first things that we had to decide when we were determining whether or not to give a person candy is whether or not they're a friend, right? So this was sort of the initial bit of the decision tree. And as you probably recall, we said the data part of this evaluation is just the yes answer to whether they're a friend, right? So at its very basic execution, we ask, is this person allowed to have candy? We see that the person is Alice. We check to see whether Alice is a friend. Yes, Alice is a friend. Alice gets candy. So that yes is our authorization data in this case. That data can then just be expressed in terms of a fact, which looks a little bit bigger than yes. But the nice thing about this is that this gives us a way to express that yes with the context that it is expressing some sort of authorization data, right? So just a yes could mean all sorts of things. Expressing this as the user Alice has a relation of friend to the user Greg now allows me to express this answer in terms that can be applied unambiguously to an authorization policy, right? And this becomes very powerful because now I have a way to express this yes in concise and clear authorization terms. I can also start asking this question in terms of this fact, right? And so I can actually represent this whole branch. If someone is a friend, then they get candy in terms of these facts. And so this rule, this determination can be expressed as, a given user has the permission to get candy from me if that user has the relationship of friend with me, right? And so this has relation user friend me is the same expression as has relation user Alice friend user Greg, right? So this is the specific data for the evaluation. This is the general expression for our policy. And this has permission is the result of granting the permission to that user based on the positive evaluation of that fact. So this can actually be extended to model all sorts of different authorization models. You can model RBAC and ABAC and REBAC, and we have all sorts of documentation about what all of those are, if those are unfamiliar terms to anyone. And you can incorporate all manner of data into this structure, whether the name of the fact tells whether it's a relation between two things or an attribute of some sort. We can model different types of data in our application, users and roles and that sort of thing, and we can specify all manner of different values for various authorization attributes. So this becomes a very powerful mechanism that allows us to express both our policy and our data in terms that can be extended as our authorization needs grow without having to change the code of the underlying service and without having to change the structure of the underlying database. So this really gives us a way to build a very effective, extensible, high-performing third-party service to manage authorization that is purpose-built to that end by using data this way. Today, we do have a couple of ways to send your application data to OSO Cloud in terms of facts. Right? So this is really the next consideration that we have. As powerful as facts are, we do still need a mechanism whereby I can take that application data and communicate it to OSO Cloud in terms of facts. We have a couple of APIs today that allow us to do that. The oso.tel API and the oso.bulk API. And they do sort of what their name implies. So oso.tel allows you to set a single fact at a given time. So you could do this in response to a user joining your organization or a group membership changing, something like that, you can call oso.tell to communicate that change in application state to the authorization service and let us know about this new authorization data. And then the oso.bulk API allows you to send a large amount of authorization data in one transaction to OSO Cloud. So these are the mechanisms that we have in place today. Shortly, Sam is going to do a demo for us of some work that we've been doing to simplify the process of getting that data. But before we do that, I thought we could stop for a few minutes and see if there are any questions that we could address before going on.
Yeah, feel free to either, you could put your hand up, unmute, put your video on and ask us a question, or if you'd rather we read it out, you can just put it down in the chat and we'll read out the question for you. Francesca, we ignored your question. Trick or treat? Greg. Trick or treat.
It would be a treat, but I can't. I don't have a good way of transferring candy across the.
I'm not in costume.
No. True. Okay.
Yeah, get out of here, Francesca. Any other questions? That was a good one. David, please go ahead.
Yeah, you mentioned in one of the slides about passing the data to, say, authorization service. In this case, it'd be OSO. So, is there any sort of limit or, say, testing or numbers we could look at that were like, what's the maximum size of data we could pass to the authorization service? I mean, I imagine you're not going to be sending like a 1 gigabyte picture or something to the service, but just as far as what sort of latency that causes if you're maybe shuttling slightly larger payloads around to the authorization service, which would be OSO.
Yeah, it's a good question. So in the kind of data we typically see people pass in that form is generally information about like one specific resource that's relevant for the authorization decision. And because of that, it tends to be, I'll put a random number, around no more than 10 is kind of what we see as the typical case. We haven't benchmarked specifically like what happens if you pass in a large amount of data. The main downside I see is like a lot of the data model we have is built so that like the data lookups are like heavily indexed, and I feel ridiculous answering this question, this pirate. Like, did anyone take me seriously right now? Sorry, yeah. We like heavily index that like database so that when we're doing those lookups, it's fast. The data that's passed in at request time, we don't go through that. We basically just pass it along as like a list to the query engine that just kind of scans through. So like that's going to scale linearly rather than like logarithmically that you tend to see with an index. So yeah, I haven't benchmarked it, but I would. It's going to depend on like how much is that data used in like the rest of the query as well, because for some of these policies they're potentially pretty deep, right? Like the friend one, you pass in a list of 1,000 friends, and then we need to go in that case, if you're in the friends list, it's a yes, so probably pretty fast. But if you're like, you need to be a friend and this needs to be true and this needs to be true, well, now you're doing like a loop through a list plus like a database lookup, and that that starts getting prohibitively slow.
Right.
Yeah, so that I would say probably like between 20 and 1,000 is going to depend on the policy, but that's probably a sign that there is maybe not a different approach that would go better.
Yeah, it's just sort of the classic sort of looping and trying to sort of almost a database problem, but
it is exactly a database problem, and we have a database to solve that problem for us, but it has its limits.
Yeah, cool. I was just curious what the sort of benchmarks, if any, exist for that.
Yeah, it's actually, as a place where actually we had a pretty big performance improvement recently in how we handle those, because we did find that it was a path on the query exit planner that could very easily produce some very like worst case behavior, and so like actually like optimizing that was like one of the things we did recently, where we did push actually more of it down to the database level so that they could optimize it better and things like that, because it can be subtle. Ahmed, I see you have a question as well.
Yeah, thanks. Thanks for the presentation, Greg. This is more of a comment than a question, but I would like your thoughts on this. So we are speaking about authorization in the context of multiple services, but it seems like even if you have a monolith, it still seems like a really good idea, because in our case, we have all our data in a normalized, stored in a normalized manner. And just asking the questions where everything is normalized can be extremely expensive. And then testing whether we are writing the queries, it just seems like a lot of work. So I'm just assuming that it makes as much sense for a monolith as much as it would for microservices. Just wanted to hear your thoughts.
That's a great question. I'll take that one as well if you don't mind, Greg. It's
Not at all.
Greg is someone new, so
Yes.
I'm gonna help with some of these questions. I didn't really introduce myself. I'm Sam, I'm co-founder and CTO. So yeah, so that's a really good point, and I agree. There are definitely benefits from having the data in an authorization system for monolith as well. The one you point out around performance being a great example. Other ones that kind of Greg touched on as well earlier, which is like the ability to have the authorization like decoupled in a central service. You can have like policies for your authorization. There are definitely tons of benefits that you get in monoliths and microservices like. Candidly, however, it is introducing additional complexity, because I think like one of the, a monolith is a very simple architecture. You have your app, it talks to a database. You're now introducing a third-party service where you maybe need to like duplicate the data to it. And that's just, it's additional complexity that does not necessarily exist in a monolith from the beginning. What we've seen is that people with multiple services, microservices, serverless, they're sort of already built or architected to deal with that complexity, because they necessarily have some form of that anyway. And so it's less of a new challenge. It's still a challenge, but it's not introducing one. In monoliths, it can just be introducing a new problem that people didn't have previously. It's a problem that we're like very interested in solving as well, though. Did I answer your question? Make sense?
Yes, thank you. Thank you.
Cool. All right, is there some great questions? Do we any more, or should we move on to the demo portion? Cool. All right, so yeah, what I'm going to show you next is some things we've been working on, and actually, very much in line with the kinds of questions that we just had, which is like, yeah, there are all these great benefits from having data in my authorization service. The question or the challenge is like, well, how do I get it there? And as Greg showed, we have a very simple API for sending that data in. It's a tell command or a bulk command to pass in a fact. It's definitely not complex and in terms of how to do that part, but it does introduce some new challenges. Like if there's like maybe a network blip, or one of the services goes down, you have your classic distributed systems problems of keeping things synchronized. And so what we've been doing also is looking for ways that we can help people with that challenge. So what I'm going to demo. Okay, so I have a little demo of a tool we've been working on that's, I'd say, an early version, but is kind of on the path that we're going for this challenge. To start with, I have a very simple Postgres data. I'm not sharing this. There we go. I have a very simple Postgres database. Much like most of our examples, I'm using a GitHub style data model where I have organizations and repositories and user kind of roles on either of those. And in particular, a thing I'm going to point out, which you'll find out why, is that, much like a regular relational database, on my repository table, I have an organization ID, and it is set up in Postgres such that this is known as a foreign key constraint. So we've kind of expressed in Postgres, I think this is maybe the part to look at. We've expressed in Postgres that this organization ID is referencing the ID column on the organization table. This is your standard like relational data model. Okay, and why this is interesting, or why this is useful for us, is this data, actually, like this kind of meaning of like there being a repository and an organization, and repositories are related to organizations, is exactly the kind of information that we want to know to do authorization. right? If I want to say, can I read a repository? I want to, like, maybe it's true if I'm an admin of the organization it belongs to. So this is the kind of data that also needs to answer those questions. So what we want to do is basically be more opinionated, be more prescriptive around how do I take the data in my database, get it into OSO, and keep it in sync. And so to that end, we have some experimental tooling for this. So first of all, I have my policy, right? It says, things like I can read a repository if I'm a reader, and I'm a reader of a repository if I'm a member of the organization. So that's my OSO policy. Don't need to remember the details of that, don't worry. But right now I have 0 data in my database. And so if I was to do things like, let's actually can't remember what people do what, but if I was to just query, what can people do? Nobody can do anything right now. Okay, so there's this new command we have that we're testing out in our CLI. It's called the reconcile command. You'll see it takes in 2 inputs, the policy itself and a connection string to my local database. So when I run this, a couple of things are going to happen. First of all, it's going to do this process of mapping the facts that are expected in my policy to the database, or mapping the database schema to the policy, right? So it's going to use that information that I just showed you, names of tables, relationships between them, to extract out what would be authorization relevant data. We apply some very straightforward heuristics. Tables correspond to resources. It's generally the data you want to protect. We have foreign key constraints between tables, corresponds to relationships between them, or has relation fact, would say, right? So when I showed you earlier, we had that repository organization ID references an organization. Well, then also knows that there is potentially a fact called has relation for a repository and an organization using those same columns. Using those same columns, the repository ID is the primary key, and the repository organization ID is that foreign key. And roles kind of works in a similar way, but is kind of looking for those many-to-many tables of users and organizations. So once we have this, right, we've now applied the sort of default configuration for how my database maps to OSO facts. We can now go through the process of just pushing that data into OSO. So you'll see it goes through and it does this reconciliation work where it looks in the database for data that matches the fact types we extracted. So in this case, we have users managing other users. We have repositories belonging to organizations. We have users with roles and things like that. And so now when I go and do my get command, I've got all that data inside OSO, and I can now start asking questions about who can do what inside my app. So in particular, I can say, what are all of the repositories that user 1 can read? Nope. What are all the repositories that user 1 can read? 1, 2, 3, 4, 5, 6, and 7. So that's kind of this is sort of the beginning of some work we're thinking around, right? And it kind of, again, it's made up of these two key pieces. One is once OSO has an understanding of what your database schema looks like, there's a lot of stuff we can start doing for you. We can start recommending how it should map to facts. When we actually shared this with somebody and got feedback from somebody recently, they had a fantastic idea of using this just to help people keep the kind of schemas in sync. So imagine I go and perform a database migration for some reason. Organizations have been replaced by an account concept or something like that. You can imagine a database migration, a linting tool coming back and saying, hey, your data structure no longer matches what the policy expected. Maybe you want to update it and add this new relation. And so there's kind of beginnings from that all the way down to maybe doing a comparison, this true reconciliation command where, say if I run that reconcile again, you can imagine we go through and we compare, well, this data is already in OSO, so we don't need to update anything. Or just, maybe do some monitoring. Hey, is this data in sync? Things like that. So that's kind of one of the paths that we're going down with this work. The other path we're going down, which I'm not going to actually be able to demo today, but the kind of thing that we can do once we have this information, once we know how data is structured inside your application, actually some of the authorization we could do in the app itself. I'm going to kind of leave that one as a teaser for some folks. But when you think around, when we were earlier talking about how much data is suitable to send to OSO. Well, one thing that we're really interested in exploring is what if we didn't need to send the data to OSO at all? We could do the kind of necessary work we need to in your database, without having to kind of replicate the authorization service everywhere. So these are some early experiments. We are currently very interested in getting feedback from folks on whether this would be a kind of tool they'd be interested in using, or if they'd just be willing on giving us feedback and trying something out, maybe pointing at your dev database and seeing if it can identify the appropriate facts. So if that's something you'd be up for doing, please drop me an email. I'm sam@osohq.com. I'd love to hear from you. And yeah, with that, that's the content that we were covering today. We've got time left to answer any additional questions if stuff came up. Thoughts or reactions to the demo or something you heard earlier you want to talk about. Yeah, we'll be. Thanks for the comment.
Cool.
Yes, I think we started recording halfway through. We might have missed the beginning of the story, unfortunately. But I think we got maybe half of the talk based on when the announcement happened. We can make that available as well.
Go through it again in a studio.
Yeah, you could always reach out to Greg and he can give you a recap. I think a lot of the content as well, I'm going to repost a link that Francesca shared, because a lot of the stuff that we spoke about today as well is covered in this blog post in some detail as well. Cool. Well, with that, thank you everyone for joining us. Do we have a final?
One more. I've lost my.
You are sharing probably the wrong screen.
Oh no.
We see the speaker view.
All right. I don't. I meant to share. Why did this not let me do that? Now are we seeing a background?
I see a desktop and terminal.
Great.
So one thing, so thanks everyone for coming today. One thing that we are announcing today is the OSO golf tournament, which is happening on November 15th. You might be wondering, is this a golf tournament at St. Andrews? It is not, but we're going to be challenging the community to participate in a logic game that we built called OSO Golf. So OSO Golf is a game designed to teach you different authorization principles using OSO's policy language, which is called Polar. And the objective is to solve specific problems using as few objects as possible, analogous to the number of golf shots it takes to reach a goal. So, for example, you might have been familiar with like regex golf or some other things like that. This is similar, but it's 9 holes. And each person who completes the challenge will receive a prize. But we're also going to have winners based on other criteria as well, like par and the time to solve. So it'll be a great opportunity to either get nerd sniped or win something cool. But yeah, we sent out the registration form in the Slack or both. Yeah. And sorry, in the chat, but we'll also send it out to everyone who registered for this event. So we'll look forward to seeing how well you swing.
Thanks, Francesca.
Cool. Well, thanks everybody for
Greg,
coming.
for the talk.
This concludes, and thank you, Sam, for the demo, and thank you, David and Ahmad, for the questions. Really appreciate it.
Thanks all.
Thank you.
Thank you all.
Bye.
Take care.
Thank you so much. See you. Bye.